You're probably familiar with L'Hopital's rule, which helps us find limits of indeterminate forms, such as infinity over infinity or 0 over 0. Here's a limit that's a little bit trickier than that. Take a look at this expression. As x goes to infinity, this part inside the parentheses gets closer and closer to 1, while at the same time the exponent is going to infinity. So at first glance it might appear as if this limit is equal to something like 1 to the infinity, which you might argue is equal to 1 because you know 1 to any power is equal to 1. However, keep in mind this isn't really 1 to the infinity. This is really something a little tiny bit bigger than 1, right? It's 1 plus 1 over x to the infinity. And if I have something a little bit bigger than 1 and I raise it to an infinite power, maybe that's equal to infinity. And so this form, 1 to the infinity, is another type of indeterminate form. So let's see if we can figure out how to use L'Hopital's rule. Take a look at this expression again. Let's just call it y. 1 plus 1 over x to the x. Since I don't know exactly what to do with this expression, let me look at the form here. I have an exponent, and in algebra, when we have a variable in the exponent, one thing we often do to get that variable out of the exponent is we take the log of both sides. So let's take that expression. Y is equal to 1 plus 1 over x to the x. And let's take the natural log of both sides. Now on the right-hand side, I have the log of something to the power x, and I can use the rule that brings that power down. I like to call that the Plog Rule. X comes in front, x ln of 1 plus 1 over x. And now let's think about what happens as x goes to infinity. As x goes to infinity, now we have a product. As x goes to infinity, the first factor goes to infinity, and the second factor, 1 over x, goes to 0, and ln of 1 is 0. So now I have that indeterminate form of infinity times 0. Still not ideal for using L'Hopital's rule. For L'Hopital's rule, we have to have a fraction. So let's take a look at this. We have x ln of 1 plus 1 over x. Let's rewrite this as ln of 1 plus 1 over x all over, so that we can have a fraction. Let's put that x in the denominator as a 1 over x. And now what happens as x goes to infinity? The numerator is going to ln of 1, which is 0, and the denominator is going to 1 over infinity, which is also 0. So now I have my form of 0 over 0, and I can apply L'Hopital's rule. So applying L'Hopital's rule, I have to take the derivative of the numerator and the derivative of the denominator. Remember, we're not using the quotient rule here. We just take the derivative of the numerator and the derivative of the denominator. So I'm going to look at the limit as x goes to infinity of, in the denominator, the derivative of 1 over x is, think about it for a minute, negative 1 over x squared. And the derivative of the numerator, the derivative of ln of something is 1 over the something. 1 over 1 plus 1 over x. And now I have to apply the chain rule. I multiply by the derivative of the inside, which once again is the derivative of 1 over x, so it's negative 1 over x squared. So take a look at what we have here. It looks a little bit messy, but I have a negative 1 over x squared in the numerator and a negative 1 over x squared in the denominator. Anything over itself is 1, so those two things cancel out. So now I'm left with the limit as x goes to infinity of 1 over 1 plus over x. The limit as x goes to infinity of 1 over 1 plus 1 over x. And now as x goes to infinity, this piece goes to 0, and my entire limit, therefore, is equal to 1. But we're not quite finished with the problem because we did not find the limit of our original y. Remember, y was equal to 1 plus 1 over x to the x. We found the limit of ln of y. What we did was we said the limit as x goes to infinity of ln of y is equal to 1. So in order to undo the ln, we have to take e to the power on both sides. So e to the ln of y goes to, in the limit, e to the 1. In other words, as x goes to infinity, y approaches e. And that is the final answer. As x goes to infinity, this expression here, 1 plus 1 over x to the x, approaches the value of e. Who would have guessed it? But that is the answer.